Bob Kleinberg from Cambridge, Massachusetts. Always a pleasure to talk at Leland Stanford Junior University. As a Berkeley grad, I never let my friends in Palo Alto forget that they're going to California's junior university, but nonetheless a very good one. Yeah, so I'm talking about methane emission controls, and in particular, the EPA, Environmental Protection Agency, proposed rule, which just came out 2 days ago. When I signed up for this talk, it was like a couple of weeks off, and I was thinking, oh yeah, for sure, they'll get it done by mid-October, and I'll have plenty of time to prepare for the meta seminar. Well, not so much. Sort of came out at the last minute. But talk's about 35 minutes long. I timed it a while ago. So there should be time for the talk and some questions, hopefully. Just going to start out with a slide that some of you saw last June when I gave that talk about the present state of EPA emission regulations. This is shows that EPA's previous attempts at regulating natural gas emissions from upstream and midstream sectors of the oil and gas industry has been a monumental failure. On the horizontal axis is dates, years over the last 30 years that the US EPA has been keeping the greenhouse gas inventory. This is all EPA data. We don't necessarily like EPA data, but it is meticulously curated. And if you want to, if you want to track changes in emissions over decades, it's really the only place to go. So that's what we're using. And you can see that over the years, the methane emissions in those two sectors has been dropping steadily, but very slowly at a rate, average rate of about 0.3% per year. Now, in 2016, President Obama promised that we were going to solve our methane problem and that we would reduce methane by equivalent of 6% a year. Well, that's not happening. And you can see where the first comprehensive rules came in 2012, basically no change in the slope of this line. So I would say that these regulations have been, in my opinion, a complete failure. And I told that to EPA during the comment period in the run-up to these rules. So as we all did, I got the rules just 2 days ago, and 800 or 900 pages. I wasn't going to read all of it. I knew that in time. So what I looked for was what I considered the most important issues to deal with. And firstly, the extension to existing facilities. This is a really big deal because most of the upstream and midstream was not regulated because of the peculiarities of the Clean Air Act and the differences between Section 111B and 111D. It's harder to regulate existing facilities. So it's only now that they've sort of caught up with that. But that's really where the bulk of the facilities are. So that's what we really need to tackle. On the other hand, you have those older facilities are mostly owned by the small producers, the mom and pops, who are extremely vocal, politically pretty powerful, and hate regulation in general, and especially anything to do with their operations. So interesting to see how EPA was going to respond to those countervailing pressures. I was also looking for emission controls on what I call the big three, which are storage tanks, pneumatic controllers, and unlit and malfunctioning flares. These three things together constitute the majority of methane emissions from the oil field. And we'll go into them in some detail during the talk, but you look at these things and you think, really? But it's true, according to EPA's numbers. So I was specifically looking for those. Finally, I was looking for my own particular special interest, which is the incorporation of new technology, including aerial screening and also continuous surveillance. I'm also interested in what's coming out of Fimsa, the Pipeline and Hazardous Materials Safety Administration, in particular the regulation of gas gathering pipelines. The US has something like 400,000 miles of upstream gas gathering pipeline. notoriously leaky, and until 2 days ago, completely unregulated, which is a scandal. We'll talk about that. So let's get on to the existing facilities issues. So I'm not going to go through this whole chart in this very brief talk, but basically there's been wave after wave of attempts to regulate methane from the oil field. And we now have 4 subparts in 40 CFR 60, all dealing with various tranches of facilities built at various times. The numbers I really want you to take away from this chart are the number of well sites previously regulated, which comes to about 110,000 as of today. 110,000, I said it right. Versus the newly regulated number of well sites, which is 700,000. In other words, in one fell swoop, the EPA has just increased by a factor of 7 the number of well sites that are falling under these regulations. Therefore, there is going to be screaming from those 700,000 new owners who are now subjected to these regulations. So, however, EPA has done some clever things to sort of mitigate the pain. For one thing, they have exempted what are called wellhead-only sites. And basically, these are sites where there's maybe a gas pipe coming out of the ground, going to a meter, then going back in the ground and off to sales line. So these very simple sites that don't have any tanks on them, don't have any separators, they are generally pretty clean. I mean, there's not much to leak on them. And so EPA is saying, okay, we're not going to worry about these. And I think that's a pretty safe strategy, which will hopefully tamp down some of the screaming. Now, there's also the next class of well sites is the smaller ones. And heretofore in the Trump administration, EPA said, well, we're not going to look at anything less than 15 barrels of oil a day, oil equivalent, but 15 barrels of oil equivalent is about 90,000 cubic feet a day, which is not that small. And in fact, we know from various studies that that those sites of that size actually did emit a lot of methane. The new rule, which I think is a lot more intelligent, is that the EPA proposes to excuse well sites that emit less than 3 tons of methane per year. That's about 1/3 of a kilogram an hour. Those are small emitters for sure. Basically, you do a one-time survey, you demonstrate there's no leaks, and you sort of get a jail-free card. I think the one and done makes me a little bit nervous. Maybe I would have wanted to see a once-a-year thing or something, but anyway, this is what they've come up with. No doubt there will be comments coming to EPA about the adequacy of this, but okay, let's assume that it works. They're also proposing that in the range of 3 to 8 tons a year, that's about 0.3 to about 1 kilogram an hour, they be monitored less often. Okay, fine, shouldn't be a problem. Interestingly, they specify in writing that surveys must include inspections of equipment most prone to large leaks and malfunctions, including storage vessels and flares. Hey, EPA, you finally woke up. So in other words, when the operators go in and determine how much leaking they've got, they got to look at the big stuff, not just the small stuff. And that is a very good change. Real departure. So just in terms of what 3 and 8 tons per year means in terms of fraction of emissions, this is from a paper that came out from EDF, Environmental Defense Fund, back in 2017. There are many such distributions of emissions. The horizontal axis is the detection threshold. Vertical axis is the fraction of emissions greater than that threshold. So basically, if you have a 3 ton per year cutoff, you're missing about 2% of total emissions from, and again, this is Barnett Shale, every basin is different, but this is kind of representative. So you're going to be missing about 2% of your emissions. With an 8 tons per year cutoff, you're going to be missing about 9%. Okay, it's not perfect, but I can live with that. You can decide for yourself. So basically, I think some real improvements in terms of basically capturing all the facilities, but not making it too onerous on the ones that really aren't a problem. So let's move on to emission controls on what I call the big three: tanks, controllers, and flares. Okay, tanks first. This is data from your distinguished junior university, Jeff Rutherford and company. And just focusing now on the left-hand bars, which are the tank bars. These are estimates of EPA in the tan bar and the Stanford group in the magenta bar. So you can see EPA estimates that storage tanks of various types, mostly water and oil tanks, are responsible for about 100,000 tons a year. 100,000 tons a year of methane emissions. Sounds like a lot, but Jeff said, no, it's not 100,000, it's 2 million, 20 times greater. Now, I think most of us, and particularly those on the call, probably vote with Jeff. His methodology seems a lot more thorough. It takes into account the super emitters, the intermittents, and all that really good stuff, the long tails that we're familiar with. It just seems to be a more careful analysis. But my gosh, 2 million tons a year? That's like a quarter of EPA's total budget on methane emissions from the oil and gas industry. So these tanks are huge. Now, the old rule that applied to new sources, and this was implemented starting in 2011, was that in facilities that emitted more than 6 tons per year of volatile organic compounds, they mandate a 95% reduction in natural gas emissions. So that's VOC, methane, and everything else. So they all getting kind of emitted together. So although methane wasn't emitted, mentioned explicitly, it was a co-benefit. Now, hey, if there's 2 million tons being emitted, I'm not sure how well this thing works. So the new plan is with the existing sources, this is the new regulation, 95% reduction from facilities emitting more than 20 tons of methane a year. So it's not 6 tons of VOC, 20 tons of methane. Honestly, I don't know which of these is a more severe constraint. This is about 2.3 kilograms an hour. My big question is, okay, how is this going to be monitored and verified? Because clearly you were not monitoring and verifying it before. So what are you doing now? Now, like I say, those documents are 800 or 900 pages in length. I haven't read them all. I have sort of done word searches, but I think this is an open question that needs to be answered. It's either in the document or it needs to be in the final rule. So that's a red flag for me. Let's look at pneumatic controllers. These are valves that are used to control the liquid levels and pressures, gas pressures in tanks. And, for sure, these are ubiquitous in the oil field. There's something like 1.5 million of them out there. EPA said you can have no controller on new equipment that emits more than 6 grams of methane per hour. 6 cubic feet of methane per hour continuously. So the industry, complying as it always does, swapped out the high bleed controllers that emitted more than 6 cubic feet an hour, put in intermittent controllers, which did not emit 6 cubic feet an hour continuously. They just did it occasionally. They're actually worse than high bleed. And the net result was after the regulation came in, as shown by the horizontal vertical line here, no environmental benefit whatsoever from this regulation. Although all kinds of valves got swapped out, nothing happened. Again, this is a scandal. So this was the state of the art as of 3 days ago. Okay, so the new rule is zero emission pneumatic controllers require all new and existing, that's every pneumatic controller in the oil field, all 1.5 million of them, in production, processing, and transmission and storage facilities to have zero methane and VOC emissions, except for some in Canada. We're going to let Canada go by. This is what is known in the administrative law trade as a self-executing regulation. In other words, basically, EPA doesn't have to do anything more than put this on the books, and everybody's got to do it. This is probably a multi-billion-dollar adventure, but my God, it will solve the problem. And we're talking about a couple of million tons of methane per year. I think this is not a bad deal. This is a really strong regulation that is very much needed. So I'm all in favor of this. Good job, EPA. Let's look at flares. So we know from the Environmental Defense Fund and others that flares are putting out much more unburned methane than EPA ever dreamed possible. EPA, so this is data from the Permian Basin. Basically, EDF found from measurements that unlit and malfunctioning flares were putting out 4 times as much methane as EPA thought. This is another scandal. Now, if you look at the regulations on flares, I've got them in a little box here, 40 CFR 60.18, there's a smoke emission limit, great. Pilot light has to be on and monitored, I'm all for it. There's an upper limit on the gas velocity, a lower limit on the heating value. These prevent the flares from basically being snuffed out by their own gas flow. But there was never any requirement that the flare actually be lit. And guess what? 5% of the flares were never lit. And these flares are some of the largest sources of methane on Earth. So what did EPA do? EPA came back once again with their 95% rule. Flares or other controlled devices must achieve at least 95% reduction in methane. Sounds good. Sounds like the tanks didn't work so well there. So again, my question is, how will this be monitored and verified? That's my red flag. I want to know. And maybe it's in the 800 pages. Maybe they need to put it in, but I'm going to be looking. Just give me another couple of days. Okay, incorporation of new technology. Let's see what we got here. So this is, I think, a pretty well-known story, and we have one of the principals in the audience, in fact. This is data from Tyner and Johnson at Carleton University up in Canada. They did a clever experiment, although an imperfect one. So they've got 167 oil and gas sites up there in Canada. They did OGI, optical gas imaging surveys, ground-based, industry standard, same old stuff. Cost about $600 a site to do it. With very high sensitivity, they discovered 379 sources in the 167 sites for a total emission rate of 74 kilograms an hour. All good. Then a year later, I mean, it would have been great if these had been done simultaneously, but okay, this is real life. A year later, they came back with their Bridger Photonics aerial survey, not nearly as sensitive, but okay, let's see what happens. They came up with only 80 sources. So instead of 379, only 80, but the total emissions from those 80 sources was more than 1,800 kilograms an hour, 25 times larger than what OGI found. And this paper, which I highly recommend everyone read, basically showed that the ground-based optical gas imager and the airplane see entirely different emission sources. They just don't see each other's sources. And it's the airplane that sees the big stuff and the ground-based camera that sees the small stuff. And so you really want to find the big stuff. So aircraft, I'm sold on it. We need to do aerial surveys, in my humble opinion. Another great example, this is on the EDF website, PermianMap.org. I hope everyone's been there many times. Data comes from Dan Cusworth's work, Flying Avarice, NG, developed at Jet Propulsion Lab. Every dot is an aerially determined methane emission site, color-coded according to rate. Dan and crew do a much better job of quantifying than just these crude bins, but it gives you the idea that every dot is colored according to how much it's emitting, and every dot is geotagged, so we know who owns it. This, to me, is how you do regulation for real. So again, this is a big argument for doing aircraft surveys, which had not been allowed by EPA heretofore. So has EPA sort of caught up? Well, yes, sort of. I mean, they're at least aware. And so they seem to say that potentially there are roles for aerial and also continuous surveillance. So I'm not going to read this whole long paragraph, but basically they propose to require screening surveys with a detection threshold of 10 kilograms an hour. That, of course, screams aerial, because that's kind of what these guys are on average. Some a little better, some a little worse. But basically, they are sort of asking the world whether this is a great idea, and the world will tell them it is. Similarly, they have identified continuous surveillance as something to look at. They are unconvinced, but they mention it, and they talk about what we need to provide them in terms of information to convince them that this is also a legitimate and in fact desirable way of finding methane emissions in this world of intermittent super emitters. Just to talk about that 10 kilogram an hour threshold that EPA seems to have kind of cottoned on to, that's again using the Barnett Shale data, and again it does vary from basin to basin. But in the Barnett, 10 kilograms an hour gives you a 60% detection. So we can wipe out more than half the problem with aircraft. And man, I am ready to do that, because that's a heck of a lot better than 0.3% a year. So that's kind of what the payoff can be. And of course, as we improve our technology and use good technology, that's gonna be going up, and we're gonna be capturing more and more of our problem. Finally, Fimsa. Fimsa surprised me. They also popped up on November 2nd. Hey, good for them. And like I said, they were in charge of 400,000 miles of notorious leaky and completely unregulated pipeline. Here's an example. This is from Kairos. So Kairos is great because they fly from well site to well site, but they don't turn off their camera in between. And they just flew over this thing, I gather, somewhat accidentally, found this gigantic emission that turned out to be a broken gas gathering pipeline. So, and subsequently, they've done enough numbers to see that this gathering pipeline system is responsible for a large fraction of all the methane coming out of the Permian Basin. It is, again, a disgrace. So what's Fimsa up to? Well, back in December, Congress, in its infinite wisdom, signed by our former president, Donald J. Trump, mandated that Fimsa make sure that their pipeline system, their regulated gas gathering pipelines, were inspected and managed to protect the environment. Okay, that's good, but what do you mean by regulated? Well, it turns out if you went back and look in Fimsa literature back there during the last administration, the only pipelines that were regulated were those that could harm human safety, which of course, when you're talking about West Texas, is practically none of them. Of the 400,000 miles, it was a tiny fraction that fell under that category. However, Fimsa has now come out and said, yes, they are actually responsible for it all. And that is wonderful, wonderful good news. The final rule came out again 2 days ago. I have not read the 170-page final rule yet, but I am optimistic that it's got to be better. Well, it is better than whatever came before. So what can we do? We as citizens, we as citizen scientists. Well, the Administrative Procedure Act, part of federal law, mandates that agencies, federal agencies, publish proposed rules and then put out a notice, what's called a notice and comment process, which means that they have to accept comments from the public for stated periods of time. Generally, it's 60 days. Now, these comments are not votes. Sending in a note to EPA saying, gee, I really like your regulations, or gee, your regulations stink, that doesn't count for anything. And EPA will put, and they say, they put more weight on a single well-argued comment than on thousands of form letters. So the most valued comments include scientific, economic, legal, or technical arguments. They are most effective if directed towards specific sections of the proposed rule. During the Trump methane deregulation exercise, EPA got 300,000 comments. I did a study of them. I classified 100 out of those 300,000 as significant. Effective comments generally came from the expected, usual suspects, the trade associations, consumer advocates, environmental advocates, law schools, good source, and sometimes individuals. Now, interestingly, EPA will read, I guarantee you, they will read and respond to significant comments. So for example, again, last year with the Trump rule, EPA issued a 638-page response document to the comments they received. Oh my God. And that was sort of condensed into 18 pages in the Federal Register. So if you write a serious comment, it'll get read. Now, that said, most arguments are rejected by EPA. Of course, they've already written their rule. They love their own verbiage and they don't want to change it. However, and I put this in highlighted orange marker, significant liberalization of rules for alternative means of emission limitation was an important exception. So what happened was there was kind of a little letter writing campaign, not so little, of all kinds of organizations saying we need more technology in terms of finding methane leaks. And a lot of people wrote that with very specific explanations and examples, and EPA wrote it into the final rule, and good for them. So it's not hopeless, but it takes, I would say, a team effort helps. Lots of letters help that are very well reasoned, and you can make a difference. So I'm going to offer myself as a clearinghouse for comments on these new rules. In the slide pack, which you'll see in the YouTube video, I have all the references to the websites and so on, and I'll send anybody this slide deck who wants it. If you see something you like or don't like, I'll help you with the comments, and here's my email address also in the slide deck. So with that, I think we can open it up for discussion and questions. Thanks.